Problem 1-88. Carlo got a pet snake as a birthday present. On his birthday, the baby snake was just 26 centimeters long. He has been watching it closely and has noticed that it has been growing for 2 centimeters each week. Letter A. Create multiple representations of the function for which the inputs are the weeks since Carlo's birthday and the outputs are the length of the snake. Letter B. If the snake continues to grow at the same rate, when will it be 1 meter long? How can you see this in each representation? We're going to start out by making an input-output table. Let's make X our input, Y our output. X is going to be the number of weeks since Carlo's birthday. That's our input. Output is the length of the snake. I got a snake, man. 0 weeks from Carlo's birthday. His snake must have been 26 centimeters long. If it's growing 2 centimeters each week, we can add 2 centimeters. It would have been 28 centimeters long. Then 2 weeks from his birthday, it would have been 30 centimeters. 3 weeks, it would have been 32 centimeters. 4 weeks, that would have been 34 centimeters. And the pattern would continue. Let's take that and graph it on here. I'm going to take my x-axis, my independent variable. This is the number of weeks. Our y-axis is going to be the length of the snake. So let's set up a scale that's going to work. I'm going to go by 5. This would be 10, 15 centimeters, 20 centimeters, 25 centimeters, 30 centimeters, 35 centimeters, 40 centimeters. And the number of weeks, we will go ahead and put week number 1, week number 2, week number 3, week number 4, 5, 6, 7, and so on. So let's plot here. So week 0, we're at the point 0, 26. Let's change the color so they stand out. Week 1, it was 28, which would be about right here. 2 weeks in, we would be at 30. 3 weeks, we'd be at 32. 4 weeks, we'd be at 34. We could continue on. Week 5, we'd be at 36. Week 6, we'd be at 38. Week 7, we would be at 40. We can connect them. This is going to be a linear function. It's going to continue up this direction. Now, we have given an input-output table. we have shown a graph. Now we need to come up with the equation. If we know that this is a constant growth, we know that it is a linear function. So we need to identify a couple key parts. Y is going to equal mx plus b. What is b? It's our y-intercept. That's what it was when he got it. So it was 26 centimeters. How much is it growing per week? Well, every week we go over, we are climbing 2, so our slope is going to be 2. So our equation will end up being y equals 2x plus 26. That is our equation. Letter B was asking us, if the snake continues to grow at the same rate, when will it be 100 centimeters long? How can you see this in each representation? So let's look here first. If our output needs to be 100 centimeters, which is the same as 1 meter, we are going to substitute it in for y. So 100 equals 2x plus 26. Subtract our 26 from each side. 100 minus 26 is 74. That's going to equal 2 times x. So when we divide it, we should end up with 37. So 37 weeks after Carlos' birthday, his snake will be 100 centimeters long. And write that on here. Carlos' snake will be 100 centimeters long after 37 weeks. Now the question asks, how can you see this in each representation? Well, for our table here, we would end up having 37 and then 100 by the time we got all the way up here. To see it here in our equation, we've already done it. We took our 100 and substituted it in. We could also take 37, plug it in for x, and our output would be 100. We'll do that. Y equals 2 times 37 weeks plus 26 centimeters. 2 times 37 is 74 plus 26 equals y, and y equals 100 centimeters. On our graph, we would have to continue on all the way to 37, and our graph would intersect the point 37, 100. That is how you can see it in each representation. We would like to thank Carlo for sharing his snake with us. I got a snake too, man. This is problem 1-88. Hopefully this helped. If not, please ask your teacher.